13 in Austin. We have now left the big player and go to what we call usually innovators, a small company bringing new ideas. And we are happy to welcome now ELSIP, which is a Swedish company. And it's a result of a long-term research made by 3 professors at the University of Stockholm. There were tons of paper, I was told. And they created a company in 2011. This company is targeting data management engine. In fact, they work on the optimization of the interconnection between memory blocks and the remaining of a circuit. And they think that they have a more global approach than what we could know from Sonics or from Arteris. I'm now glad to introduce Bengt Edlund, which is our sales and marketing of this company. And the first question is, of course, you believe in your innovation. Have you contacted the industry? What do you think today?
Thank you. Thank you for the good question. Yeah, the challenges of the industry has grown tremendously as people realize that you can't just throw frequency at this problem. You have to go parallel. And once you do that and you go heterogeneous architectures, you also run into the memory wall problems. You have to have a smart NOC, for example, and Arteris and Sonics are fantastic examples of that, being very successful. However, when you design a solution, and specifically the transport of data, the access, the synchronization of data between the cores and the memories in a distributed architecture, which actually overcomes the problems of the memory bandwidth problems, as well as the NOC in combination. You really have a fantastic opportunity to take a different look at this, and this is what our professors did for 7 years. They've researched this. They actually were very early in the NOC and writing papers about the NOC and inventing almost the terminology NOC, together with other people, of course. But in that element, you see that the big companies like the Intels and the Freescales, they have ways of customizing the IP, and they overcome this by handcrafted designs. And what we wanted to do is basically bring this opportunity to more companies than the big ones by taking the knowledge they have acquired over so many years into a building block that allows other people to also build heterogeneous architectures with many processor cores in a structure that actually works and scales linearly to the number of processors you add, and not just collapse after 15, 16 cores.
So do you mean that your interconnection technology is really general purpose, that many people in different areas could use it?
Yeah, I would say so. We could use it either as a soft IP block, which is roughly 35,000 NAND gates in a normal traditional ASICs design, SoC, or with an FPGA from Xilinx or Altera as a hard IP block. So it works both ways.
And you think that the performance are good enough when it's generic, a little bit generic?
Yeah, actually, I think, if you look at the 2 ways of doing this, you can do it either as a software or as a hardware solution. Today, most people do as a mix of the two. What we see is that our hardware solution is as flexible as the software solution, while it provides the flexibility of a software solution without the penalty of a higher power consumption. So absolutely, and it scales up to thousands of cores.
So you come from Europe, and do you think it's easy to create a company in Europe and to be successful?
Europe is a good birthplace, and if you look at the latest research that comes out of Forbes and a lot of the papers, Sweden is ranked as a top country and the Scandinavian region in the world of actually creating new companies and new IP. So we're top 5 in all 3 investigations. So I'm very happy to be in Europe, in Scandinavia. It's a good place, and it's where innovations are being born.
Okay, so we wish you a lot of success, and next year with a lot of customers, I think so.
Absolutely. Thank you very much.
Thank you.